Today we're going to solve linear systems, and we have some word problems for some examples. Our first word problem says John works at Paul's Pizza and Subs and was given 2 orders. April ordered 4 slices of pizza and 3 sodas for $7.95, and Casey ordered 2 slices of pizza and 2 sodas for $4.20. What are the individual prices for pizza and sodas at Paul's? So the first thing we have listed here is what do I know? I'd like to pull everything out of that paragraph form and list it. And I have April's order, 4 slices and 3 sodas for $7.95, and Casey's order for 2 slices and 2 sodas, which costs $4.20. So from this piece of information, I see I have 2 groupings. One is April's order and one is Casey's order. So what I have here is I have 2 separate equations. So I also need to identify what each variable is going to stand for. P is going to equal the price per pizza, and S is going to equal the price per soda. So here is April's equation, and here is Casey's equation. So I have 2 variables and 2 equations, so it's a linear system. We know we can solve linear systems through graphing or elimination method or substitution method. Graphing is an option, not necessarily the easy option. And the previous lessons I've done, we've only done more problems using substitution. So this time I'm going to take a look and try to solve it using elimination. So I'm simply going to rewrite what I have here. 4p plus 3s is equal to 7.95. And here's Casey's equation with the 2 slices of pizza and the 2 sodas, which equals $4.20. Now, I need to check a couple things. They are in standard form, so I'm all set there. If I add these together, I'm not going to eliminate one of the variables, so I need to do something to one of the equations. I notice right here with my coefficients for my p that I have 4 and a 2, and I know that if I multiply my second equation by -2, I'll get a -4p, which is what I want in elimination. So let me recopy the first equation. 4p plus 3s is equal to $7.95. I need to multiply every term by -2 in my second equation, so I have -4p minus 4s is equal to -8.40. So now when I add these equations, my p's will zero out, which is what I want, and I'm left with -s is equal to -0.45. Now I divide everything by -1, and I have s is equal to 0.45. So a soda is equal to 45 cents. That's a pretty good deal. Now I need to substitute this s in to either of my original equation, doesn't really matter which one, to find out how much a slice of pizza is. So if I take my second equation, I have 2p plus 2 times 0.45, because that's how much a soda costs, is equal to $4.20. And then that gives me 2p plus 0.9 is equal to 420. Subtract my 0.9, and I have 2p is equal to 3.30. So a slice of pizza looks like it costs $1.65. Okay, so this is going to be my soda. My soda price is 45 cents, and this is going to be my slice of pizza. Slice of pizza is going to be $1.65. Now if I wanted to double check my work, I could substitute both of these values into each of my original equations just to verify that I didn't make any computation mistakes. Our next problem deals with money. It says a collection of nickels and quarters is worth $12.30. There are 66 coins in all. How many of each type of coin are there? So again, I made a list of what I know. $12.30 is our total. We have 66 coins. The other thing we have to add is how much the value of the coins are. So nickels are obviously 5 cents and quarters are 25 cents. So we need to figure out what we're going to do with this information. So we do have information about how many, and we also have a money amount. So I'm going to do 2 equations. This time we're going to have one with quantity and one with money. So my quantity, I know if I have n plus q is equal to 66, because over here we already labeled that n is the number of nickels and q is the number of quarters. So n plus q is equal to 66. My money equation, 5 cents, so 0.05, that's in a dollar amount, nickels plus 0.25 quarters is equal to $12.30. Now I could do this either substitution or elimination. This one I'm going to try using substitution. So I'll get n by itself. N is equal to -q plus 66. And now what I'll do is I'll go to my other equation, and anywhere I see an n, I'm going to plug in that expression. So I get 0.05 times negative q plus 66 plus 0.25q is equal to $12.30, 12.3. So now I distribute that 0.05, and I get negative 0.05q plus 3.3 plus 0.25q is equal to 12.3. Now again, there's my wall, so I have to combine my terms. I have negative 0.05q and 0.25q. So that'll give me 3.3 plus 0.20, or 0.2q, is equal to 12.3. Subtract the 3.3 from either side, and I have 0.2q is equal to 9. Again, divide both sides by 0.2, and q is equal to 45. So there's 45 quarters. I can go back up to my revised equation here and realize that n is equal to negative 45 plus 66. So n is equal to 21. So there are 21 nickels and 45 quarters. So that's my final answer when we were asking how much of each type of the coin are there. Now I could again go back and double check my work, plugging it into both of my original equations. The quantity equation is easy. 21 plus 45 definitely gives me 66, and I can double check it with money to make sure that 21 nickels and 45 quarters is the right combination. Now our last word problem today involves a multiple choice question. So let's see what we have. It says Samantha and Maria purchased flowers. Samantha purchased 5 roses for X dollars and 4 daisies for Y dollars each and spent $32 on flowers. Maria purchased 1 rose for X dollars plus 6 daisies and spent $22. And our multiple choice question, when we're looking at what we're asking, it's asking about some true statements. So we need to solve this to figure out how much each daisy and each rose costs before we can answer the multiple choice question. So again, let's first start with Samantha. So it tells us that Samantha has 5 roses for X dollars and 4 daisies for Y dollars, and she spent $32. So that's for Samantha. If we look at an equation for Maria, we have 1 rose for X dollars and 6 daisies, and she spent $22. So that was for Maria. So again, the X and Y is a dollar amount for each. So X is equal to the price for a rose, and Y is equal to the dollar amount for a daisy. Now again, I could solve this either using substitution or elimination. I'm going to use elimination. So I'm going to multiply the bottom equation by negative 5. So let me rewrite what I have. So I have 5x plus 4y is equal to 32. That's my first equation. And I get negative 5x minus 30y is equal to negative 110. My second equation, my x's will eliminate, which is what I want. And then I have negative 26y is equal to negative 78. Divide both sides by negative 26. And I have y is equal to $3. That's per daisy. Now again, I can substitute that back into my original equation. So I have 5x plus 4 times 3 is equal to 32. So 5x plus 12 is equal to 32. 5x is equal to 20. So x is equal to $4. That's per rose. So now that we have our values for each, we can look at our multiple choice questions and see what we can eliminate or what we're confident is correct. It says in letter A, Samantha spent over 4 times as much on daisies as she did on roses. So let's look at that. We have to do a little math on that one. So she spent 4 times on daisies as she did on roses. Well, let's say Samantha bought 5 roses for $4. So that's $20 she spent on roses. I'll put an R for roses. And then she bought 4 daisies, and they are $3 each. So that gives her $12. That's on daisies. So let's go back to A. She spent over 4 times as much as daisies as she did on roses. Well, that's not true because she actually spent more on roses. So A, I can cross it off. That's not true. Letter B says Samantha spent $4 on each daisy. Well, that's not true because we know that the daisies has a price of $3. That's not true. And actually, both girls spent the same amount for their flowers. There weren't different prices for each girl. So we know that the B is not correct. And let's look at letter C. It says a rose costs $1 more than a daisy. Well, a rose costs $4 and a daisy costs $3. So that's true. So we're not going to cross that one off that one. That looks pretty good. And the last one, letter D, says Samantha spent more on daisies than she did on roses. Well, we already have Samantha's kind of worked out here. Remember, this was Samantha from part A. And she did not. She did not spend more on daisies than she did on roses. So that one's not true either. So I know in this case that letter C is my correct answer. A rose costs $1 more than a daisy. Now, one thing you can also learn from this question is when you have a multiple choice question, you should look at all 4 options. If A seems correct to you, you shouldn't just stop there. Remember, the other 3 options are meant to be a little trickier or are meant to maybe make you think a little bit more. So you want to make sure you go through all 4 options and not just pick the first one that seems like it's correct.